We're going to take a look at linear number patterns. Now, we have been exposed to number patterns since grade 8, but actually what we may have noticed is that there are number patterns all around us. And one of the most common types is this linear number pattern. So what we have here is the general term for a linear number pattern. And in a linear number pattern, we have our general term here, Tn, that basically represents the term and then the number of the term in subscript. And then the A value here is what is called the constant difference. So in order to make a linear pattern, we have to be adding or subtracting the same number every time. This B value can be found either by substitution or by simply subtracting the constant difference from our first term. So let's dive into some examples because that is really the way that we make sense of linear number patterns. Given the linear pattern 9, 5, 1, and then it goes on and on and on, all the way down to minus 143, we are asked to determine the formula for the nth term of the pattern, then calculate the value of T7. So basically what they're saying is calculate the value of the 7th term, because here we are given term 1, term 2, term 3, etc. So they want the 7th term there, and then determine the number of terms in this pattern. So let's have a look at how we would go about determining the formula for the nth term of a pattern. Now, earlier we had a look at the general term, which said that Tn is equal to An plus B. All right, now to find A, we need to figure out the constant difference. And to find B, we can say term 1 minus that constant difference, and we will have the B value. So let's take a moment to look at this pattern. We are given the following terms, 9, 5, and 1. And what we can do is we can figure out what do we do to 9 to end up at 5. And the answer is we subtract 4. What do we do to 5 to end up at 1? Again, we subtract 4. This is known as our constant first difference, and that is the A value. So A is equal to minus 4. Now to get B, we take our first term, which is 9, and we subtract our difference. Be careful there. We are subtracting a negative number, which means that we are in fact adding, and 9 plus 4 is 13. So now we can answer the question and we can say Tn, the general term of this pattern, is equal to minus 4n plus 13. Next up, they would like to know the value of T7. So I can then say term 7. And now what I'm going to do is everywhere there was an n in my general term, I'm going to substitute it with a 7. So term 7 is going to equal minus 4 times 7 plus 13. And that gives me an answer of minus 15. And then finally, they would like to know the number of terms in this pattern. So if we have a look, what we do know is that the last term here is equal to minus 143. So what I can do is I can take this general term that I've worked out and I can say, well, if it is equal to minus 143, what would the value of n be? So we're going to start by moving this minus 13 across. Minus 143 minus another 13 gives us minus 156. And then I can divide both sides by minus 4. And that gives me an answer of 39. And so there we have it. We can find a general term by working out the value of A and N. We can find a term number by substituting that term in. And finally, we can figure out how many terms are in a sequence by equating the last term to the value that we were given of minus 143. Let's have a look at a second example. Given the linear pattern 2x plus 2, 3x plus 4, and 5x plus 6, determine the value of x. Hence, that means use what you've just worked out to determine the nth term of the pattern. And then finally, which term in the pattern is equal to 108. So let's have a look. What I know is that my terms are going to be separated by these semicolons. So term 1 is equal to 2x plus 2. Term 2 is equal to 3x plus 4. And term 3 is equal to 5x plus 6. Now, what I can do is I can use the fact that they have said that we are dealing with a linear pattern, because that means that there is a constant first difference. So whatever I added or subtracted to get from term 1 to term 2, I will do the same thing to get from term 2 to term 3. And so what I can do now is I can simply equate those. If I were to take term 2 minus term 1, it should be equal to term 3 minus term 2. And now all I need to do is substitute in and solve. So term 2 was 3x plus 4. I'm subtracting the whole of term 1. So once again, be careful there. Look at those brackets. Those are going to help me not to make any sign mistakes. And then term 3 is 5x plus 6 minus term 2, 3x plus 4. All right, now before I simplify this any further, I'm going to take this negative and multiply it into the bracket, and I'm going to do the same on both sides. So this is going to give me 3x plus 4 minus 2x minus 2 is equal to 5x plus 6 minus 3x minus 4. And now I'm going to collect like terms on each side. So I'm going to collect x's with x's, and constants are going to go with constants. And that's just going to help me in solving this equation. So we've got 3x minus 2x, which is just 1x. Positive 4 minus 2 is plus 2. Is equal to, on the right-hand side, we've got 5x minus 3x, which is 2x, plus 6 minus 4, which is plus 2. And then I'm going to collect all my x's on one side and all my constants on the other side. So let's see how that changes things. We're going to move this across. It's going to become a minus on this side. And we're going to move this one across. And it's going to become a minus on this side. So we're going to be left with x minus 2x is equal to 2 minus 2. And so we end up with minus x equals 0. And that means if we divide both sides by a negative, x is equal to 0. So there, by applying the fact that the constant difference is equal, we have been able to work out the value of x. And so now what I can do is I can substitute that in, and I can actually figure out what this sequence is all about. So we've got 2 times 0 plus 2. We've got 3 times 0 plus 4. And we've got 5 times 0 plus 6. Okay, and if you remember correctly, anything multiplied by 0 is just 0. So this sequence becomes something very straightforward. 2, 4, and 6. That really helps us when we get to question 2, which asks us to determine the nth term of the pattern. So what they're asking for is Tn, the general term. Okay, we know Tn is equal to An plus B. We also know that if we can find the constant difference here, that's the A value. So 2 plus 2 gives you 4, and 4 plus 2 gives you 6. So A is equal to 2. And we can calculate B by taking our first term, which we worked out to be 2, and subtracting our difference, which happens to be 2 again. So there we have a B value of 0. So to answer the question there, Tn is equal to 2n plus 0, which we don't generally write. So I'm just going to write it lightly over here. It's not wrong if you write it, but we don't need to write a plus 0 there. And then finally they say which term in this pattern will be equal to 108. So again, I can apply this formula that I've just worked out, Tn is equal to 2n, and say, well, what will n be when 2n is equal to 108? And that's an equation for me to solve. I'm going to divide both sides by 2, and I'll be left with n is equal to 54. Let's look at one last example here. Consider the pattern formed by the matchsticks below. So what we've got is someone who is playing around and they have formed. With 4 matches, they have built figure 1. And then what they've done is they've added on, there's figure 1, and they've added on 1, 2, 3 matches. So with 7 matches in total, they have built figure 2. And then, what do we notice? This is figure 2 with 1, 2, 3 more matches added. So with 10 matches, they have built figure 3. So what they ask us next there is how many matches would be required to build figure 4? So what do you notice, grade 10s? We notice that each time we are adding another 3 matches. So the next term there would simply be 10 plus 3, which is 13. Next, they ask us for the general term, Tn, okay, or the nth term. These are just different ways of saying the same thing. They are asking us to give the formula for this number pattern. So Tn, we know, is equal to An plus B. A is the difference, and B we can work out once we have that difference. So let's take a moment to consider the terms that we've got so far. We've got 4, 7, 10, and 13. I can work out a constant difference. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. So that means the A value there is going to be 3. And then to get the B value, we would simply say B is equal to our first term, 4 matches, subtract the difference, B is equal to 1. And so now I can write my general term down. It is 3n plus 1. All right, and you can test it out by saying, well, if I were to sub in a 3, would it work? What's 3 times 3? It's 9. 9 plus 1 is 10. Yes, there are 10 matches in figure 3. And then finally, they say, how many matchsticks would you need to create the 100th figure of this pattern? So in other words, what they are asking is not, will you use 100, or which pattern uses 100 matches? No, they're saying, how many matches to create figure 100? So they are asking us for T100. So I've got my general term, and everywhere that I see an N, I am going to interchange it now with 100. So 3, I substitute using brackets, and so I end up with 300 plus 1, which means 301 matches will be required to create the 100th term or the 100th figure in this pattern.